Hello, this is Miss Moore, and today during chemistry we're going to continue our discussion of functional groups, specifically carboxylic acids. Carboxylic acids. Carboxylic acids are organic compounds with a carboxyl group, which is COOH. In a structure, you would probably see that written as COH, and the C, whoops, I didn't leave myself enough room there, bonded to, double bonded to an O. So this is your carboxyl group, and then the rest of this would be hooked on to your hydrocarbon. Okay, so carboxylic acids are weak acids. Why do we call them acids? Because they ionize very slightly in aqueous solution to give a carboxylate ion, which is this here, and the definition of an acid, a hydrogen ion. So when carboxylic acids are dissolved in water, they release a hydrogen ion as well as a carboxylate ion, which makes them an acid. Carboxylic acids are very common in nature. Acetic acid, which is vinegar, is a carboxylic acid, and fatty acids are carboxylic acids. Naming carboxylic acids. Honestly, it's not much different than what we've been doing so far. So that you find the parent chain, which is the longest chain, but this chain, the longest carbon chain, but this chain must contain the carboxyl group, right? And once again, the carboxyl group is going to look something like that. When numbering the carbons, the carboxyl group is always on carbon number 1. That's important. Besides that, you follow the alkane naming rules, except change the ane ending to anionic acid. Okay, and that'll make more sense in a few. Okay, let's try this. Let's start by finding our parent chain, and we have a 4-carbon chain, which makes the prefix but. We have a carboxyl group, so instead of writing, this would be butane, but we're going to change the ending to butanoic acid. Okay, so we still have a butane, but we add the oic acid, so butanoic acid. Let's try one more. Start by finding the parent chain, which again is right down the middle. And that's 2, 4, 6. That's 6 carbons, which makes it with all single bonds. So it's a hexane, except again, we have a carboxyl group. So we're going to change that from hexane to hexanoic acid. This time we also have some branches. We have 2 methyls. Now that means this time we have to number our carbons. So do we number from left to right or right to left? Do we look at the closest branches or something else? Well, if you remember, look at point 2 here, when you number carbons, the carboxyl group is always on carbon number 1 when there is a carboxyl group, which means we need to number right to left. So this will be carbon 1, 2, 3, 4, 5, and 6. So we have 4-methyl and 4-methyl. And we already determined that the parent chain is called hexanoic acid. So we're going to have 4,4 dimethyl hexanoic acid. All right, so the big change for today is that whenever you see something like this in the green box, you're going to change the name to ionic acid. And I spelt that completely wrong, didn't I? Nobody stopped me. There's nobody here to stop me. Let's change the spelling. It should be N-O-I, O-I. There you go, oic. All right, so once again, whenever there is a carboxyl group or the thing in the green, you've got to change the ending to oic acid. And whenever there's a carboxyl group, you have to start numbering from that position, that carbon. All right, that's it for today. Have a good one.